This video, you're watching the third lesson on ratios. This video will talk about the application of ratios in real life uh, in a specific area called scale, right? So scale is the concept of making things bigger or smaller for whatever purpose you need it for. And we use ratios to represent scale. And scaling things bigger or smaller, or up or down, is used in many, many jobs. For example, an architect will scale down a building either to draw a picture or to make a model before actually making the building itself or designing the actual building in a one-to-one scale, because you don't want to make the building and then realize it doesn't work, right? So scale is used to make either things easier to make or to make things easier to see by making them bigger. So here we have a picture of a grasshopper, and we say that this is a scale of 1 to 1. And a scale of 1 to 1 means that the grasshopper we see here and the picture of the grasshopper are the same size. So the picture of the grasshopper is actually this big, and the grasshopper is the same size. If we were to do a scaled down or a smaller picture of the grasshopper, we would say, of half, we would say that the picture is a scale of 1 to 2. 1 being the picture and 2 being the original grasshopper, right? You can say that if this is the size of the original grasshopper, this is half of that. And if you wanted to scale up the picture, we could say that if we wanted to make this 2 times bigger than the original size of the grasshopper, we would say that the picture is 2 and the grasshopper is 1. Because the relationship is that this picture is 2 times bigger than the original grasshopper. And so we'll go into more detail explaining what scale is, but this is essentially, in a nutshell, what scale is all about. So scale is the relationship of size with a new object to the original version. So we have the original rectangle in this picture, and we have a scaled rectangle. And so we have a length of 12 and a height of 4 and in the original, and in the scaled rectangle we have a length of 3 and a height of 1. And so what would the scale be to the rectangle, to the scaled rectangle, to the original rectangle, right? How would we represent the relationship of size from the scaled rectangle to the original rectangle? Just like how this 2 to 1 ratio here shows the relationship of the picture of the grasshopper to the original size of the grasshopper, right? So when you show an object, when you show scale, when you show two objects and you're trying to show their scale, the new object is represented by the first number, right? So the new scaled object, so in this case, this one, this scaled rectangle, is represented by this number in the ratio. And the original rectangle, the original shape, is represented by this number, right? So the first number is your represents your new or scaled shape, and the second number represents the original drawing or the original object that you're comparing it to. So we look at this. So if the object is larger than the original, then the first number will be equal to the number of times larger it is. So to make this a little bit easier to understand, we go back to our grasshopper drawing. This grasshopper drawing is 2 times larger than the original grasshopper. So right here, the new one, or the drawing, is 2 times larger than the original. So this drawing is 2 times bigger than the original, so we use a 2 to represent the first part, the first number of our ratio, and a 1 in the second part, because we're saying that the grasshopper drawing, or this picture of the grasshopper, is 2 times bigger than the actual grasshopper itself, right? So if you go back to this one, 12 to 4, 3 to 1, right? So you can say that if we were looking at our scaled rectangle, the new number is the scaled, right? The new rectangle is scaled. So we put the first number as its relationship. And so we can see that this is 4 times smaller than the original. So we can represent this as 1 to 4, right? It's 1/4 the size, or 1 to 4 the size of the original, right? So we know that the new picture is smaller than the original, so the second number should be larger. The second number will show how many times larger the original is. So if we have a big picture of the grasshopper, right? If this new picture, this scaled picture of the grasshopper is bigger than the original, then your first number will be the larger number, and the second number will be usually 1, right? But if we're looking at a scaled shape that is smaller than the original, then the second number will be bigger. The second number will be showing how many times larger the original is to the scaled one. So again, once again, we see that the original is bigger than the scaled rectangle. So how many times bigger is the original? Just like before, we see 12 and 3, so you should know that 12 is 4 times larger than 3, and 4 is 4 times larger than 1. So we can say that this rectangle, this original rectangle, is larger than the scaled rectangle, and it's 4 times larger than the new scaled rectangle. So we can use 4 to denote how many times larger this rectangle is, the original rectangle is, to the new scaled rectangle. And then we do a 1 there, right? And that's how you represent scale. This is saying that our scaled drawing, the new drawing, is 1, and the original is 4, right? So you're saying that this scaled rectangle is a 1 to 4 relationship to the original rectangle, right? How many times larger is the original? So we can see that the original is 4 times larger than the new one. So the second number will be 4. The original is 4 times larger than the new one, so the second number will be 4, and the new number, the new rectangle, will be represented as 1. These numbers represent the relationship, not the actual height, right? Yes, the height is 1, but we don't put a 1 there. The reason why we put a 1 there is because the original rectangle is 4 times bigger than the new one. So try and take a look at these two and see what the scale ratio is. So we have the original at 235, and we have the new rectangle at 470 centimeters. What is the scale ratio? So pause the video, see if you can do it on your own. All right, so if you pause the video and solved it, this is how you do it. So we see the original, so we'll just start off with a blank ratio, and we look at the original. Okay, well, first off, we know that the original is smaller than the new scaled rectangle, right? This new scaled rectangle is 470, and the original is 235. Okay, well, if the new one is bigger, how many times bigger is the new one to the original? Well, it's 470, and this is 235. Well, it's about 2 times bigger, right? It's 2 times bigger. So the new one is always represented in the first section of our ratio, and the original is always represented in our second number. So our ratio, since the new one is 2 times bigger, we would put a 2 here, and the original is 1. So it is a ratio of 2 to 1, because the new scaled rectangle is 2 times bigger than the original rectangle. So what is the scale ratio of this one? We have 102 to 34, right? Well, we know that the new one is bigger than the original, so again, we'll draw a blank ratio. And again, the first number represents the new drawing, or the scaled drawing, and the second number represents the original, right? Represents the original. Well, again, the new one is bigger, right? How many times bigger is the new one to the original? Well, we can go, all right, 102, all right, and 34. Well, it's about 3 times bigger. Okay, so the new one is 3, right, representing the new one, and the original is 1. And that's the scale ratio. Again, we can do the same thing here. We have a circle with a diameter of 24 centimeters and a circle with a radius of 12. What is the ratio from new to the original? So pause the video, see if you can solve it. It's a bit tricky, but hopefully you can see the trick. All right, so if you pause the video, we're going to take a look at this. The original circle is 24 centimeters, right, across. And the new one has a radius of 12 centimeters. Now, if you know the difference between radius and diameter, you know that sorry, it's not perfect because the line doesn't go all the way, but you know that the radius is halfway across. So if it's 12 halfway across, then it's 12 the other way across, which means it's also 24 across. So that means that the original has the same size as the new one. So you would say, okay, well, it's 1 to 1 because they're the same. They are equal. And that's it. That was a tricky one, so hopefully you don't fall for that. So when do we see scale being used in everyday life? Well, maps, right? Maps need to be scaled down. You can't really have a map the size of the United States if you're trying to travel in the United States, right? It would be very impractical to show a map on a 1-to-1 scale because you would actually have to unfold a piece of paper the size of the United States, which defeats the purpose of having a map to begin with. So they scale down the image of the United States or of Canada or whatever country you're trying to get through, and they show you that scale on the map. So in this picture, the one I found was for Atlanta. In this picture, you can see that the ratio or the scale is 1 to 94 million, in the sense that 1 inch or 1 centimeter, 2 centimeters, 1 centimeter equals 940 kilometers, right? They've scaled it down to such an intense level so that you can just open the map and it sits in your lap rather than being this huge thing. And as you zoom in, you have a larger and larger scale, right? Sorry, as you zoom out, you have a larger and larger scale. So the scale factor is the number to show how big or small the new image is. This can be found by turning the ratio into a simplified fraction, right? So the original is 5 and the new is 10. So the scale ratio would be 2 to 1. Well, then at the ratio as a fraction would be 2 over 1, and that's the same as saying 2, right? You just 2 divided by 1, remember? Fractions are the same as division. Never forget that. 2 divided by 1 is 2. So when I say scale factor, if I say find the scale factor, I'm asking you, well, what is the relationship? What is the number the new shape or object is relative to the original object? So in this one, we have 10 centimeters across, or whatever unit it is in the new one, and the original being 5, whatever units they are. And so the scale ratio would be 2 to 1, but the scale factor would be 2. This is saying that the new rectangle is larger by a factor of 2. It's 2 times larger. So if we have an original of 10 and we have a scaled down version, because it's obviously smaller, of 5, the scale ratio, it shouldn't say ration, it should say ratio, would be, well, once again, you should be able to solve this on your own from the practice we did. The first number in the ratio represents the new one, and the second number represents the original, right? So the original is bigger. How many times bigger is the original? Well, 10 is 2 times bigger than the new one, so we would say the original one, or the second number in our ratio, would be 2, and our first number would be 1. It's a 1 to 2 ratio. So the scale factor would be 1/2. So you just divide the first number by the second number, or you could just turn it into a fraction, right? So you could also represent the scale factor as a decimal, right? As 0.5. You could also do that as well. And that would be just as valid. So to find the scale factor of your scale ratio, you just divide the first number by the second number, right? And it's just like turning it into a fraction, because if you had a scale ratio or a scale where the new one is bigger by a certain number over the first one, then you would have a whole number, right? So in this one we have 2 to 1. 2 divided by 1 is 2. So the scale factor is 2. Here we have a scale ratio of 1 to 2. 1 divided by 2 is 1/2, or 0.5. So you'd say the scale factor is 0.5, or you could just say 1/2. Right? So what is the scale factor of this original to the new one? Pause the video, see if you can do it on your own. And then you can also do the second one as well. All right, so again, we make our ratio, dot, dot. Again, the first number represents our new shape. And our second number represents our original, right? Don't forget that. So we know our new one is bigger than our original. Okay, how many times bigger is the new one to the original? 24, 48, you should know that 48 is 2 times bigger than the original. Well, if the new one is 2 times bigger, we put a 2 there. And if the original is smaller, then we just put a 1 there. And so now we have a scale ratio of 2 to 1. Well, what's the scale factor? What's the scale factor of this ratio? Again, we just take the first number and divide it by the second one. 2 divided by 1 is 2. So we have a scale factor of 2. Okay, let's take a look at this one. We have an original of 42 and a new one of 14. Okay, so we have an original of 42, whatever units they may be, and a new one of 14. Once again, the first number in your ratio represents the new scaled version, and the second number represents the original version, the original shape. So here we have the original being bigger than the new one. How many times bigger is the original to the new one? Okay, well, the original is about 3 times bigger than the new one, so it would be 3, right? Because it's 3 times bigger. And the new one is 1. So it's a 1 to 3 ratio. That's our scale ratio. What's the scale factor? Well, 1 divided by 3 is either 0.3 or 1 over 3. And you can represent the scale factor as either a decimal or a fraction. Now, if you have a whole number, 2 divided by 1, in this case here, you don't want to write it as 2 over 1, because that's an improper fraction, and you don't want to give your answers as improper. So if the new one is bigger than the original, then you probably want to keep it as your scale factor as a whole number. And if your new scaled down version of the shape is smaller than the original, then you can show that answer as a decimal or a fraction. So scale is a bit of an odd sort of thing, but it's applied in many jobs and many things in everyday life. So it's actually important to understand how scale factor, and scale ratios work. So hopefully this was helpful, and I'll see you next lesson.